In this video, I'm going to talk about formation of alcohols using carbonyl compounds or reducing carbonyl compounds. Okay, so formation of alcohols from carbonyl compounds, and we are going to reduce them. Reducing carbonyls. So first let's talk about the common reducing agents which we are going to use in this reduction reaction. First is sodium borohydride, NaBH4. It has a structure like this, Na plus and BH4. Okay, and this was a negative charge. And there is another reducing agent which is lithium aluminum hydride, LiAlH4. Sometimes it is abbreviated as LAH. The structure is similar to the previous one. Here lithium is the positively charged species, and we have aluminum with 4 hydrogen atoms attached to it and with a negative charge. This is more powerful reducing agent, and this is a milder reducing agent. This being very powerful reacts violently with water. Okay, reacts violently with water. So you have to be very careful using lithium aluminum hydride, making sure that the flask or the reaction flask is completely dry when performing these reactions in a lab. Now both can be used as reducing agents to reduce carbonyl compounds to alcohols. Remember, we talked about oxidation state of alcohol being lower than that of ketones or aldehydes. So you can reduce aldehydes and ketones or esters and carboxylic acids to form alcohols. So let's write a general reaction first. Here I'm going to take show an example with R double bond O and another R, that's a ketone. I can use sodium borohydride, NaBH4, then followed by water, and I result in the formation of an alcohol of this kind. Okay, so what kind of alcohol is this? This is a secondary alcohol. So ketones can be reduced by sodium borohydride or lithium aluminum hydride. You could also use lithium aluminum hydride for the same reaction. I will write LaH followed by water, and you can end up in getting the same product. Okay, so you can either use sodium borohydride or lithium aluminum hydride with a ketone to give a secondary alcohol. Now if you have a aldehyde like R double bond O H, right? This is an aldehyde, and again the same thing, you react it either with sodium borohydride followed by water or lithium aluminum hydride followed by water. You will get an alcohol which is actually a primary alcohol. Okay, so with aldehydes and ketones you get primary alcohol, and with with aldehydes you get primary alcohol, and with ketones you get secondary alcohol. Now let's look at the mechanism of this reaction. Okay, mechanism. Let's take an example of ketone here, R double bond O R, and if I use sodium borohydride, okay, can draw like this, BH H And now I'm going to use a different color here to show the hydrogen that's on the borohydride. The reaction is where the hydride attacks this carbonyl carbon, forming a tetrahedral intermediate. So we get O. Remember this pair that we already had a pair of electrons here, 2 pairs, and now we get the other pair. Oxygen gets a negative charge. We have the 2 R groups, and then we have this new hydrogen from the borohydride. Here. Now we do the next step of the reaction, where it reacts with water. So I'm going to write water in this manner, and this is the complete step. R, now the hydrogen, and then OH. So very simple reaction. First step is the reaction of sodium borohydride. This acts as a nucleophile hydride, attacks the carbonyl carbon. I should probably keep the bond also as a color here to show that the hydrogen came with the pair of electrons as a hydride. Okay, so we have an H minus that is attacking the carbon atom. We have a tetrahedral intermediate. Which then reacts with water in the second step to form the secondary alcohol. Okay. Now let's take another example using lithium aluminum hydride, but this time let's use an alcohol as our starting carbonyl compound. Okay, so let me write it down here. So this is another example 2, or maybe we can use another page here. Let's use another page, and R double bond OH. Now I'm using an aldehyde, and then I'm going to react it with lithium aluminum hydride just to see the mechanism of this reaction. Now again, lithium aluminum hydride, we can show a different color to the hydrogen atom in this manner to show the attack. Here I use this arrow, pair of electrons, or the pi electrons move on to the oxygen, and what I end up is another tetrahedral intermediate. I have a tetrahedral intermediate with negative charge on oxygen atom. I have the hydrogen, and then the new hydrogen or the hydride from the aluminum hydride is here shown by the red color. Okay, then what will happen in the next step? Reaction with water. So reaction with water, again I'm showing water in this manner, and then formation of the alcohol. But now what do you see? It's a primary alcohol, right? It's a primary alcohol. So aldehydes give primary alcohol, and ketones give secondary alcohol. Okay. Now we can do a similar reaction with esters and carboxylic acids too. Carboxylic acids and esters give only primary alcohols. Okay, and they can only be reduced by using lithium aluminum hydride. So if you have an ester, so for example, the mechanism is slightly different. Here I'm going to show you only the reaction. That means if you have a carboxylic acid or an ester, this is a carboxylic acid, right? Remember, they can only be reduced with lithium aluminum hydride, and you will need excess of lithium aluminum hydride. And again, remember, you have to do it in 2 steps because this reacts violently with water, so you cannot add water in the first step, and you end up in a primary alcohol. Okay, and similarly, if you have an ester, remember this is ester, so if I write it as OCH3, this is an ester, you again need excess lithium aluminum hydride. Remember, sodium borohydride will not work for reduction of carboxylic acid or ester, so you need lithium aluminum hydride, and you end up in primary alcohols. Okay, so primary alcohol with carboxylic acids. So this is a carboxylic acid, and the second one here is an ester. Okay, so I'm not showing the mechanism here, but this is what you will get. Carboxylic acids can be reduced to primary alcohols, and esters can be reduced to also primary alcohols, but only with lithium aluminum hydride. So remember, sodium borohydride does not reduce carboxylic acids or esters. Carboxylic acids or esters. Okay. All right. Now let's move to the next reducing agent, and that is Grignard's reagent. Okay. So let's look at a reaction of Grignard's reagent with a ketone or aldehyde. So when a ketone or an aldehyde is reacted with Grignard's reagent, they can also be reduced to alcohols. So first of all, what is a Grignard's reagent? So if you recall from, this is a Grignard's reagent, recall from Chem 235, the general formula of Grignard's reagent is RMgX, where R can be an alkyl group or aryl, and X can be a halogen. So if you have a CH3 Br and you react it with magnesium, magnesium can insert itself between these two, the alkyl group and the halogen, and what you get is a Grignard's reagent. So this is a Grignard's reagent. Let me abbreviate Grignard's reagent as GR, and so this is your Grignard's reagent. RMgX, so R can be an alkyl group, magnesium is the element that's necessary in Grignard's reagent, the metal, and then we have the halogen. You can also have aryl groups like this, where you take an aryl bromide, react it with magnesium, and you can end up in this MgBr. Now, how can we use them to reduce aldehydes and ketones? So the reason is that in a Grignard's reagent, magnesium is highly electropositive. So we have a polarity here. Carbon is more electronegative, it gets a negative charge, and this is a positive charge. So as a result of which, this can act as a very good nucleophile and attack any electrophilic center. So if you have a carbonyl compound of this kind, let's take a ketone, okay, and if I react it with a Grignard's reagent like a CH3 MgBr, what do I get? There is a negative charge, there is a positive charge, right? So the negatively charged nucleophilic center attacks over here, puts the electron here on the oxygen atom. You get a tetrahedral intermediate like what we saw before. So oxygen gets a negative charge, and you have the R, and then you have the CH3 coming from the Grignard's reagent. Okay. Now in the next step is where you add the water molecule, where the negatively charged oxygen is protonated, and finally you end up in a alcohol, right? So this is an alcohol. What kind of alcohol is this? It's a tertiary, right? Because R groups are alkyl groups, and CH3, we have another carbon here. So 3 carbon atoms, carbon attached to 3 carbon atoms gives you a tertiary alcohol. So that means if you take ketones and react it with Grignard's reagent, you get tertiary alcohol. Okay, and if you take a aldehyde and do the same thing with the Grignard's reagent. I'm using the same Grignard's reagent. You can vary the Grignard's reagent while you're practicing these reactions, and you can see that the same similar type of reaction, you get a tetrahedral intermediate with oxygen being the negatively charged species here. And second step is where you add the water in this manner. Negatively charged oxygen gets protonated, and we end up in the alcohol, which is here we have a secondary alcohol. Okay, when we use ketone, you get a tertiary. When you use aldehyde, you get a secondary. So here again, care has to be taken that water is added only in the second step, because Grignard's reagents are powerful bases. They can react with water, and they can deprotonate the water. So it's very important that you do the reaction in two steps. First step, you add the Grignard's reagent and then add the water in the second step. Okay, so let's look at an example here. So if I ask you what will be the product of this reaction, so I'm taking a ketone here, and again remember to add the Grignard's reagent first. So say for example here I'm using a CH3 CH2 MgBr. Okay, this is my Grignard's reagent. I change the alkyl group, and then the second step I add water. So if you are asked to write down your final product, remember this carbonyl gets reduced to OH, and then this part of the Grignard's reagent is attached to that carbon atom. So I end up in a tertiary alcohol. If I had a aldehyde of this kind and asked you to write down the product using this Grignard's reagent, again remember water has to be added in second step. Now if the product is asked, you know that the carbonyl carbon is this one which we get the OH, and then you have your CH3 attached to this point. So what do I end up with? This is a secondary alcohol. Okay, so practice as many examples you can using these three reductions which we talked about. One with sodium borohydride, second with lithium aluminum hydride, and third with the Grignard's reagent. Now Grignard's reagents can also react with esters to produce alcohols. Okay, but make sure that you practice a few more reactions with these reagents. Okay, all right. So that we will talk about reactions of alcohols in our next video.